Hello statistics students, this is Emigh, and this video is our discussion on section 8.4, testing a claim about a standard deviation or variance. Let's start with this example. Listed are the heights in inches for a simple random sample of supermodels. Use a 0.01 significance level to test the claim that supermodels have heights with a standard deviation and therefore variance less than the general population, which is 2.6 inches. Use the critical value method. Okay, to start testing a claim, we use two capital H's, a sub naught, a sub 1. The decision to use sigma right here came from test the claim that supermodels have heights with a standard deviation. That's how we made that decision. We always use an equal sign for the null hypothesis. Our decision to use a less than sign came from right here, the wording in the claim. And then the 2.6 inches is the standard deviation for the current population. Okay, the next thing we want to do for the critical value method, just erase that stuff so it doesn't get too cluttered, is sketch a graph. Well, this question is about standard deviation and variance, which means the data takes on the chi-square distribution, and therefore it's all in the first quadrant like you see here. We are going to cut off the left tail, and the reason we know to cut off the left tail is because of this less than sign right there. And then I like to shade in the rejection region. Okay, the next thing we need to do is find the critical value that creates that rejection region for us. And we're going to do so by running the program Math 200B. So let's do this together. Take your calculators out. All right, hit Program, which is right below Stats. Scroll down to Math 200B, open that program, and then hit Enter a second time. We have 7 options here, and what we're using this program for at the moment is to find our critical value for chi-square. So we scroll down to option 4 and open that program. The first thing it wants from us is the degrees of freedom. Well, the degrees of freedom is in less 1, which is 10, because we have 10 heights there, less 1, making that 9. Ooh, wasn't supposed to be equal sign there. Supposed to be a minus sign. 10 minus 1 equals 9. Okay, so enter that. And the next thing it wants from us is the area in the right tail. Okay, well let's label our areas then. Our significance level of alpha is 0.01, and that is the shaded region. And therefore the complement for the unshaded region would be 0.99. Okay, so the area in the right tail, or to the right of the critical value, I should say, is 0.99. Enter that, and then just wait a moment. It takes a second to calculate it, and if you got 2.087900736, you ran that program correctly. Nice job. All right, so our critical value is 2.088, approximately the 3 decimal places. Okay, the next thing we need to do is find the test statistic, and we're going to use the formula chi-squared equals n less 1 times s squared divided by sigma squared. All right, we have everything we need to run this program except for lowercase s. What I mean by that is we have the sample size, that's 10. We have lowercase sigma, that was given to us right here as 2.6. It's the population standard deviation. But we don't have lowercase s yet, which is the sample standard deviation. So we're going to enter all the data values into list 1 and run one variable stats. So let's do this together. Go ahead and hit stat, hit enter for edit. In L1, clear out any old data you might have and list the heights here. 70, 71, 69.25, 68.5, 69, 70, 71, 70, 70 again, 69.5 for the last one, and then we hit stat, scroll over to calculate, open up the program, one variable stats, list L sub 1 for me, frequency list you can leave blank, and then run that program. And what we're looking for from that program is, on your output screen, it looks like a capital S lowercase x, but that would actually be a lowercase s sub x. So our sample standard deviation is 0.7797395. If you got something different, check your data. You may have just typed one value in incorrectly. Okay, so we now have everything we need to apply this formula, which would look like this. Be careful typing that in. Use your parentheses carefully. Use your up caret for the squared or the squared key. And if you enter that correctly, you will get 0.852 for our test statistic. I'm going to switch to blue just to really highlight where 0.825 is on this graph. It's definitely in the unshaded region, somewhere maybe there. This is our test statistic, so TS, which is approximately 0.852. Okay, our test statistic did not fall in the rejection region. Therefore, we are going to reject the null hypothesis. What did I do wrong here? Our test stat is not in the rejection region. We should be failing to reject the null hypothesis. What am I doing wrong? Ah, I see what I did wrong. I put our test statistic in the wrong spot. I was thinking that 8 is bigger than 2. Let me erase where I put our test statistic. Oh no. That back up there. Okay, rejection region here. Going back to blue, our test statistic of 0.852, my apologies, does lie in the red rejection region, 0.852. So we will reject the null hypothesis, and we would word our conclusion: there is sufficient evidence to support the claim that supermodels have heights with a standard deviation less than 2.6, and therefore their heights have less variation than the general population. All right, let's do another example. The standard deviation of math scores at one high school is 16.1. A teacher claims that the standard deviation of boys' scores is greater than 16.1. A simple random sample of 30 boys results in scores with a standard deviation of 16.3. Use a 0.10 significance level to test the teacher's claim. Okay, so we're going to set up our null and alternative hypothesis, two capital H's, a sub naught, a sub 1. The reason why we use sigma right here is because the teacher made a claim that we are being asked to test about the standard deviation, so that's why we're using sigma. We always use an equal sign. The reason we're using the greater sign in the alternative hypothesis is because of this wording of the claim right here, greater than. And we use the 16.1 because that is the school-wide standard deviation. Okay, I'm going to erase all that so this doesn't get too cluttered. And the next thing we want to do is sketch a graph. And we used a greater than sign this time, so it's going to be a right-tailed graph. Chi-squared, shading in the rejection region. And we're going to find the critical value that creates that rejection region, as well as the test statistic. See where that lies, and that will make our decision for us, help us make our decision. Let's label our alpha significance level of 0.10 as the shaded region. And just to write a complete graph here, the complement would be 0.90, and that is the unshaded region. Okay, so if we apply that same formula, we get a test statistic of 29.725. And if we run Math 200B, we get a critical value of 39.087. So let's put each of those on our graph now. Our critical value is 39.087. Now I'll switch colors to the test statistic. The correct side this time. 29.725 is closer to 0. That's our test statistic. And it shows, or we see here, that our test statistic does not fall in the rejection region. Therefore, we are going to fail to reject the null hypothesis. And our conclusion would be there is not sufficient evidence to, we say support the claim that, and then restate the claim the standard deviation of boys' scores is greater than 16.1. All right, and that will finish our discussion on section 8.4. Thank you for joining me. See you next time for our discussion on section 9.1.